My name is Nellie Shaul, and I'm a third-year grad student at the Scripps Institution of Oceanography, and I'm in the marine chemistry and geochemistry group, and my research now focuses on organic pollutants and how they move through the environment. My background is in chemistry and biology, and I started off studying synthetic organic chemistry and then doing a master's in environmental chemistry where I looked at organic pollutants in human tissues, which brought me to looking at them in the environment. I wanted to mimic what is done in the environmental field when you're thinking about maybe an emerging pollutant coming out, or just how the EPA goes about its process from start sampling plan to finish and disseminating the results. And so I had several activities, everything from water sampling to analyzing the water for different organic compounds, looking at what those compounds might be doing when they're in the water through a toxicity test with live organisms, to then looking at how we can present that data and disseminate our findings. So mimicking the real process, and the kids were actually looking for different baking and cooking spices in those water samples, and it was a way for them to look at things that are similar to my research, organic pollutants, but not necessarily using things that are toxic or bad. My activities were all done in an AP environmental science classroom, and then often implemented a second time in a biotechnology class. These were all 11th and 12th graders. I would often have them do assessments like writing essays about applying what they learned to like a real world problem, and seeing them write things in terms of having them design a method for something that we hadn't talked about in class. And they came up with some really interesting ideas. I think the most engaging things that we did were actually going out into the field and doing the water sampling. We went together as a group, and it was kind of a whole day field trip, and the kids really enjoyed that because then they were also able to make other field observations that are common to just ecology in general. And also working with the live organisms and the toxicity tests, that really got them very engaged, and they were excited to be looking under the microscopes and adding chemicals to them and seeing what would happen. And it's because I think I didn't really know what was going to happen with a lot of the stuff that they did, and so they were doing, you know, real stuff. My favorite part about this whole Socrates experience was definitely working with the students, and it was specifically seeing them actually make connections in the classroom through my activities. They were dealing with some concepts that I don't feel like I even got a good handle on until I got to college. And so seeing them have that sort of aha moment when things started to click, and they were able to connect something from something that they learned in chemistry to a concept that we were learning about in, say, environmental science or biology, that was definitely the most rewarding and best part. As scientists now, we're sort of barraged or berated with, you must be able to, you know, tell what you do to other people, because science is in the news a lot more lately, and politicians are having to make decisions about science. It seems to me that it's not just about the teaching, but it's about being able to take what you do as a scientist in the lab in your little hole of a research field, and being able to break it down into its component parts so that anybody can understand. And that's a skill that I don't think just is important for teachers, but everybody in the sciences.